All right, so here at the bottom of 260, we're going to start talking about how do we do other transformations. We've talked about these two parts of this function. We've talked about if we have an A and if we have a B. We already said that this A is going to affect the amplitude. It's going to affect the height. It's going to affect the high point, the low point of the sine curve or of the cosine curve. We also talked about B. B affects the period. We talked about how the period is always going to be 2 pi divided by B. But we haven't talked about H and K yet. What happens if we have an X minus H? What kind of a shift? To the right H, right? And what would a plus K do? It would take all of our values up K. So if it's a plus K, it's up K. A minus K is down K. All right. And then what if we had a negative out in the front? What would that do? We flip over the x-axis, right? Okay, now, if we have a shift up or down, whatever that shift is, it's going to be called the midline. In pre-calc next year, you might also see it called the sinusoidal axis. Okay? I'll show you that as we go along. You're always going to find the 5 key points by translating those points however is necessary. Let's do this first. It says in your notes, you're going to have to add it. Write a rule for G that represents the indicated transformations. If we start with the function f of x equals 6 cosine x, we're going to translate 3 units down and pi units left. So we want to think, what would that new equation be? Does anyone know how I could take it 3 units down, Ainsley?
You put minus 3 after.
Okay, at the very end, I put in minus 3. Good. And then how would I take it pi units left? Tyler? Right. So it's going to look like this then at the end. 6 cosine. The x would get replaced with x plus pi minus 3. That's going to keep the same amplitude. It's going to shift pi units left and 3 units down. If I wanted to see what that new function looked like, you should know how to graph it on your calculator. Go to y equals. We're just going to type our new one in. I'm going to put in 6 cosine of x plus pi minus 3. Now, you want to check your mode. You could actually be in radians or degrees, but just so that all of our calculators look the same, let's go to radians under mode. Then we're going to have in our function, which we do, anytime you have a trig function, you want to do a zoom. Which one do you think?
Trig.
Trig, yes. So here's what this function looks like. This will give us a good graph, maybe not the best because I can't see the bottom of it. So if I go to my window and I extend this down lower, maybe to -10, and now I can see the whole thing. And I can tell, see right here, down 3 units, that's going to be that sinusoidal axis. So right here, down 3 units, this is called that midline or the sinusoidal axis, right there. Can you see that the amplitude is 6? See how that works? And then cosine normally goes -1, 0, +1, but now our amplitude's been stretched. And we also had a shift to the left pi. So here's our +1, 0, -1, 0, +1, because of that shift to the left pi. Any questions? All right, let's try the next one now. So now we're going to have the function 1/2 sine pi x. We want to translate 1 unit up, and then we want to reflect over the line y equals 1. So the easy part is the translation 1 unit up. What's that going to do? Just add 1. So my first step would be 1/2 sine of pi x, that's really in parentheses, plus 1. Now, here's where it gets tricky. If I wanted to reflect this over the x-axis, the whole thing over the x-axis, I'd multiply the whole thing by -1. That would reflect the whole thing over the x-axis. But if I only want to reflect it over the line y equals 1, it's like this. It's like I want to be up here at y equals 1, but instead of going 0, up 1/2, 0, down 1/2, like that, I want to reflect over this and I want it to go down first. I want it to go like that. So I don't want to multiply the whole thing by a negative because then it's really going to shift it down 1 unit. That's not what I want. So if I just wanted to open the opposite way, go the opposite way, I'm just going to put the negative in front of the sign. So see how that's going to look now? Okay, wait until I'm finished. And I want you to see how this looks. So see how short that amplitude is? That amplitude is just -1/2. But see how it still is a shift up 1? And then it goes down 1/2, there, up, like that. You see what I mean? Whereas if I put the negative around the whole thing, in other words, if I put it around the whole entire thing, now watch what happens. See how now it really shifted it down 1 unit, so that wasn't the right thing to do. Okay, let's go to the big part here, which is the very end, with the graphing. We're going to do this one. So what we want to do is we want to come up with these key points. So we're going to make a table of values. Normally our table of values, we use those quadrantal angles. Those quadrantal angles are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Do we know the key points for sine? What are the key points there? Good. Okay, so we've got that part. But now we have to see what else is going to happen. If we have this 1/2 here, we're always going to take care of that first. That is going to be a horizontal stretch by 2. Remember how it's the opposite? It's a horizontal stretch by 2. So what's that going to do to all my x's? Double them, because it's a horizontal stretch by 2. So all these are going to get doubled. All right, what about this now? What's that going to do? Shift to the left or right? Right. Left is not right. Right is right. Pi, 2 pi, 3 pi, 4 pi, 5 pi. So everything got shifted to the right pi. So now we've taken care of that. So we've taken care of this, this, and this. Then what's this plus 1 going to do? Up 1. And those are going to be the 5 key points. So let's say I'm taking a test and I don't feel real confident about that. Go to y equals. Type this in. Sine 1/2. Then you need another parentheses. X minus pi. We need to close this one and close that one. And then plus 1. Everybody type that in. Now, if I just go right now, I want to check this table. So I go to table. I hit second table. What? That's not what I expected to get, right? But that's because my table isn't set up right. Where do you see the table set up? Above window. So go to second window. We have to set up our table. Where's our table starting? Pi. So I need to say start at pi. How much is our table going up by every time? Pi. So I need to make this pi. And now watch. When I go back and look at this table, see there's my key points. 1, 2, 1, 0, 1. See that? So now I know that table is correct that I created. And so now it's time to graph it. So I'm going to call this 2 pi, 4 pi, 6 pi, 8 pi, negative 2 pi. I'm just going to call this 1 and this 2. You can do it however you want. Now, we're going to want to graph over this entire graph. Okay, so I know I have this point pi 1, 2 pi 2, 3 pi 1, 4 pi 0, 5 pi 1. Well, this pattern goes on forever. See, this is what I've got so far. But it goes on forever. So my next point, there, continue the pattern. Shoot, did I miss one? No. And then go backwards with the pattern. You should be able to continue that pattern forever if you had to. Okay? Makes sense on the graphing? All right. So on your homework, though, guys, it's going to tell you to graph every single one. I don't care if you graph every single one. Graph 2 of them. Graph 1 sine, graph 1 cosine. I want you finding this. Because I think if you had this, couldn't you all do that?
Oh, just do that.
Yeah, just plotting the points, right. So just do this. Okay, let's do this last one here. You need to change it from what's on yours. G of x equals 2 cosine x plus pi over 2 minus 3. Make your table of values. Normally we go 0, pi over 2, pi, 3 pi over 2, 2 pi. What are the key points for cosine normally? Say them loud.
1, 0, negative 1, 0, 1, 0.
Right. So this is what it would normally be, but now we have to look at what's going on. What's this 2 going to do?
Divided by 2.
No, that would be if it was in front of the x. It's not in front of the x. It's in front of the whole thing. What's it going to do? Multiply only the y's. It's going to be a vertical stretch by 2. It's going to change these y's. Okay, so we took care of that. We've already done that. What about this? What's this going to do? Left pi over 2. So subtract pi over 2. Got that? Check. Now what? Is that going to affect my x's or my y's? Y's. Subtract 3 from every y. Oops. That should be a negative 5. All right. Now, I want to check my table. So I'm going to go to my y equals, put in 2 cosine x plus pi over 2 minus 3. I have to set up my table. Where's this table starting?
Negative 5, 2.
How much is it going up by every time? Not pi. Pi over 2. And now when I look at my table, I should see my key points. Negative 1, negative 3, negative 5, negative 3, negative 1. Good. So I know it's correct. Okay? You're going to be allowed to use a graphing calculator, but you still need to be able to do this without having to use it. That's just to check your work. You should be able to do it both ways. Any questions, Isaac? I have to go under y equals. I have to put in the function. I go to my table setup, which is second window. I say the table is starting at negative pi over 2. Delta table's the change in the table, just like in physics, delta's the change. Do that, now you can look at your table. Okay? A lot of people say, yeah, you have to be in radians to do this, but let me show you this too, guys. Let's say that I had my calculator in degrees. If I had my calculator in degrees and I wanted to check my table, where would my table now be starting? What's negative pi over 2? Negative 90. How much am I going up by every time? 90. And watch now when I look at my table. Oops. What? Did I change it into degrees? Maybe it didn't take care of that. Oh, here's my problem. What do I have to change that to? 90. Now when I look at my table, see how now it's okay?
Wow.
Isn't that cool?
So then you have to change the degrees and the radians.
Yeah, so you have to make sure everything's in degrees or everything's in radians. But I just always use radians because it's just the more standard way of doing it. Okay? But it's pretty neat.